Okay, so let's start today's class. Actually, I'm planning to have two more lectures. Uh, though I've told you about that last class that this would be the lecture 12 is the last class, but I thought that in the earlier days of this semester, I have told you that I will talk about some embedded system communication protocol. So I think I should discuss about the LoRa protocol with you. So that is why on Friday I will take the class on LoRa protocol, and hopefully today I can finish it off the external serial interfaces. And next week we will spend for the last class test and uh, lab assignment or lab task. Let's start. Oh, it's decreasing. Uh, 1 minute back it was 7 students, now 6 students. Okay, hope others will join very soon because I have to finish with it today, and in the next Friday I will finish all the lectures. Okay, basically today we'll talk about the external interfaces, fine, but all the interfaces will be serial interfaces. Okay, and today we'll talk about some wireless interfaces as well. And all of those interfaces are external except one. So uh, let's see that which interfaces we'll talk about today. And actually, this is the hierarchy of the course, and so far we have covered all those. Today we'll talk about the serial IO interfaces, that is called USART controller. This is an internal interface, but along with, after discussing about 8251 serial IO USART interface, we'll talk about the other external interfaces. And most of the interfaces names are known to you. I'll just discuss some of the features of those interfaces. So let's start. Uh, so first of all, that in every types of communication or in every type of interfacing, we need some connection, and some connection concepts are there. And to make the interconnection or interconnectivity between the integrated circuits, we should follow some model for setting up the rules or for setting up the protocols. So let's recall the OSI model. I think you all know that what is Open System Interconnection Model, because it makes the connectivity between the sender and receiver entity. Okay. Now this sender and receiver entity might be from the computer networks, from the wireless communication point of view, from the uh, printed circuit board or motherboard point of view. So all of them can be mapped. All those sort of communication pattern can be mapped within open system interconnection model. And this is an umbrella model, you can say. And within that umbrella model, we do define our protocol. Likewise, you have seen the protocol like CAN protocol, Control Area Network Bus protocol, that was used for automotive vehicles or large scale embedded systems. You have seen the, just a minute, and you have seen the inter-IC bus protocol or I2C bus protocol that is designed for uh, small scale embedded system. And hopefully for IoT in the next class, I'll discuss about one specific protocol, that is the LoRa protocol, and long range communication protocol, or you can say, but with a lower speed. And so that also follows some of the properties of OSI model. So actually we have two types of standards. One is EIA. This is for external interfacing. For external interfacing, we have two types of standard. One is EIA, another is USB. Nowadays, this is the most popular. Actually, this is removing all the other components or all the other IO interfaces from a computer system. And even in every devices, even in every circuits or every motherboards, we have an option of USB. And also we have some other peripheral interfacing standards that provide power, flexibility, and ease of installation, like FireWire. We'll discuss today. You may heard the name of SCSI or Internet SCSI, and InfiniBand fiber channel. These are used for communication or networking purpose for high-speed connection. And today our target is to study this. So first, we'll start with the UART or USART. So first of all, this is an internal interface. This is not an external interface. So this is an internal interface, and through this we design the communication port EIA 232F port. And UART, this stands for Universal Asynchronous Receiver Transmitter, and another is USART, this is Universal Synchronous Asynchronous Receiver Transmitter chip. So you have seen the name. One is only asynchronous, and it supports both synchronous and asynchronous. So this is more versatile. And the microprocessor sends and receives the data to and from to UART or USART in parallel, while with IO, the USART transmit receive data serially. Okay. So towards USART, the microprocessor sends the data in parallelly, but towards peripheral devices, the USART or UART sends the data serially. So you can see one figure. I can show you this figure. That this is a particular USART or UART type IC, and it is on the left side, as usual in this course. And throughout this course, I have shown you that our main concentration is on this particular block diagram, because we have covered the CPU, and mostly we know the peripherals is at the right side, though no peripherals we have shown here. And in the intermediate place, or in this location, we have all sorts of interfacing ICs. So today our talk has started with the new IC type, that is the 8251, and this is an 8251 is an UART or USART IC. And what are there? Within this, we have the status register of 16-bit, and you see this is the data register or data buffer of 16-bit. So you see from the microprocessor, the data comes to the data buffer. Sorry. Imran, any question? Okay, so I got one problem. My power has gone at my home. Hopefully it will come. If it doesn't come, please stay connected. I will be connected through mobile data. Okay, so you see that, and we have a transmit receive buffer as well that actually interacts with the outer world or with the peripheral world. And we have various versions of 8251 or likewise this sort of IC. One is 8251 USART, 8250, or in other name you can say 16450. UART is the newer version of 8251. See, the naming convention though is work with 8251, but later on the version is 8250, but the name is this one. The original name is 16450, and the latest version of UART is 16550. So you see, one thing is that we have removed the serial synchronous part. We are only dealing with the UART part in the latest versions. So from here we can claim that the UART that interacts with the outer world asynchronously. And you know what is asynchronous communication and synchronous communication in our earlier classes. So this is the 16550 is the latest version of the UART, but though this is the latest, but we'll talk about the 8251, the architecture of 16550 a bit complex. We'll just understand the simple one. Now, sorry. The 8251 is a programmable serial communication interface chip designed for synchronous and asynchronous serial data communication. But nowadays, the latest version doesn't support the synchronous one. But 8251 supports the serial transmission of data, and it has a package of 28 pin in dual inline package. So this is the block diagram. This is the pin diagram. So these are the 28 pins, 1 to 28 pins you have. Okay, now from here you can see that we have on the right side, on the left side we have the data bus buffer. We have the read-write control logic, as usual, the read-write, and you are already been familiar with this logic that these are connected with the microprocessor, and we have the reset clock pins, chip select pins. We have some modem control, modulation and demodulation purpose, and you see, you might heard the name of request to send RTS signal, clear to send CTS signal, data transmit signal, and most probably data synchronization. Okay, and we have some on the right side. These parts are connected with the external world. One is transmit buffer with transmit control, another is receive buffer with receive control. So we have some signalings or pin names for the USART or UART. Next, this is the pin diagram, but today I will not go in details of the operations. Rather, my focus is to make you introduce with some external interfaces. So this is an interface. 8251 is an interface where this resides within the printed circuit board, but it connects with the outer world through the serial port. The serial port is EIA232. We say this is a serial port or communication port. Now I'll talk about the USB. This is solely an external interface. This is a newer standard that is more powerful than EIA232. Okay. Now you may ask that how the EIA232 looks like. So it looks like most of you might have used it. So it looks like a VGA cable, VGA port. Have you seen that? Likewise, this sort of port is there in your most of the earlier days computer system. This was available. Even nowadays, we find this sort of port. Have you seen that?
Yes, sir. Behind monitors.
Behind the, yeah, for connecting the monitors. Though we connect the monitors nowadays with HDMI or DVI port. Nowadays, the substitute of this is HDMI or DVI port. Okay, but still nowadays the motherboard or the computer system supports both HDMI and the EIA232. And for EIA232, internally we use the 8251 or latest version 16550 UART. Now alternate is USB for making the data communication. First of all, for making the data communication, and USB interface is the modern standard for interconnecting a wide range of peripheral. And you know, universal means that universally it is applicable for all sorts of IO devices. The most easy feature, or it makes our life easy, is that it supports plug and play. we don't need to uh, actually don't need to install the driver software automatically nowadays, as it is universal. So in the operating system directory, we have a directory named system32. There all the manufacturers have given their installation images, driver images there, and if we connect that connect any new device or any new USB device, that will be identified from that database, from system32 directory, and from there the driver will be automatically installed. And now it might be it is easier for our life that we don't need to bother about the driver software of any new devices. Those are connected through USB. And another feature is that it can make, we can through USB, we can make daisy chain multiple devices. So we may connect hub wise, and most of you have used the USB hubs. And through USB hub, we can connect many devices. And nowadays, that though we say type A, type B, type C USB, but so we have some other names, USB 1, USB 2, and USB 3. And what is the basic difference? The basic difference is the data transfer speed. And you see that USB 1 can support 12 Mbps of data transfer in between the peripheral to the computer system, whereas USB 2 can support 480 Mbps or 60 megabyte per second or 480 megabit per second. Or USB 3 can support 5 Gbps or 640 megabyte per second. Now, if I show you some of the technical details, more technical details of USB, I'll talk about this. The universal serial bus is very common, and mostly nowadays we can connect our printers, scanner, digital cameras, and all sorts of other peripherals like keyboard, mouse. Those can be connected. And the term plug and play, easier plug and play is called. It has a technical term, that is the hot swapping. Hot swapping means that you can plug and unplug it while the computer is on. And as we can make the daisy chain, so now the typical standard is allowing 128 USB devices at the same time using hubs in a chain. So this is another thing, and already we have shown you the USB 1, USB 2, and USB 3's maximum data transfer speed. And USB connection, another thing is that USB connections to also provides power to the other devices, and you know that nowadays we are charging all sorts of devices through USB ports. Okay, next. Let's see some electrical component and mechanical component. First of all, this is a typical structure. We have two types of structure. One is, this is a rectangular, and this is a horizontal. Okay, this is a horizontal shape, and this is the most common we use in our flash drives nowadays. We are using this, and like camcorder or digital cameras, those uses this. Now, the electrical component defines two wires. One is V bus, another is ground. So you see that this is the V bus and this is the ground. Actually, one for power, voltage bus, and another for ground reference. And we have the D plus and D minus, that is for data transmit and receive. That means D plus and D minus wires carry the data to and from, and it also carries some signaling. It also carries the control bus purpose, because signalings are also being transferred to and from the computer system to the peripherals. And what sort of signalings? Like transmit, receive, these signalings are interrupt related signalings. So these D plus and D minus are used to transmit and receive. And you can think over it from the point of view of computer system. And regarding the mechanical component, it precisely defines the size of the four different connectors. These are the four different connectors and uses only four wires. And the wires are the metal shell counts as one or more connected. And you see there here as well, we have the D plus and D minus, D plus and D minus, V bus and ground. So this is called standard A USB. This is called standard B USB. So another thing is that nowadays we are using USB A type, B type, C. This is in other way we can say four types of USB connectors. This is USB A. This is USB B. It looks like this, and I've told you that in nowadays in digital cameras we are using this sort of USB. Even for mobile devices, we are using this sort of USB. And this is another type, mini connectors. So this is all about the USB. The main technical details I have discussed here. Now I will talk about some other connectivities and other external interfaces. The next interface is FireWire. You may heard the name of FireWire, and this is a local digital interface, but it can be connected in real time with the PC. And a FireWire connection lets you send data to and from with a high bandwidth digital devices such as digital camcorders, and it's faster than USB 1. It is not faster than USB 3, but of course it is faster than USB 1 because USB, when it was introduced, at that time USB 1 was in the market. And it was first introduced with a high speed of 400 Mbps, and it is also what swappable or what pluggable, means plug and play, you can use this. And another thing is that it supports both synchronous and asynchronous communication, and but from asynchronous point of view, it supports isochronous communication. I think I have talked about the isochronous communication when I have talked in your data transfer mode before the midterm. Can you recall that? What is isochronous? You know asynchronous, I know, but isochronous is a special type of synchronous communication where the delay jitter means whenever you send some periodic data one after another with a fixed interval of the fixed interval may vary. So okay, still my connection is. Am I audible?
Yes, sir. মাঝখানে একটু কাজ চলেছে।
Okay. Okay. So isochronous means it looks like, suppose at a whenever the data rate is very high, so let's say the periodic interval is, say this is the data transmission time, and let's say the periodic interval is 10 milliseconds. So every time it maintains the 10 milliseconds, and it's a synchronous communication pattern. But let's say that data transfer rate is a bit low, but with a lower speed. Okay, so it means it has a 20 milliseconds of interval. 20 milliseconds of interval. So you see that this is called isochronous connection or isochronous data transfer mode, where actually the transmission interval is defined with two time variables. So this is called delay jitter. So isochronous is supported by FireWire. that fireware it supports with a IEEE standard because whenever any interface comes to the market, it should be standardized some standardized body. And you see that even for USB, we should follow some electrical component and mechanical component. These are standardized by some standardized body, and it is also standardized by IEEE 1394 task group. Okay, my power has come again. Okay, this is no problem from my side, inshallah. Okay, it was standardized by IEEE 1394 task group, and it was originally developed by Apple Computer. And this is just a history for the Macintosh computers. But later on, Sony picked it, and for their, and you know, Sony camcorders were so much famous once upon a time. And also for some high definition TV devices also use the fireware, but nowadays mostly the TV devices uses the HDMI. And for the home theater, for the sound devices, once upon a time we have used the fireware as well. Okay, now the fireware has some versions. Okay, and you see that fireware was the standard interface that was used first by Apple iPod, and once upon a time iPod was so famous, and it is also supports hot swapping with 63 firewire devices can be connected at the same time. So for USB it was 128, and for firewire it is 63 firewire devices can be connected, and it was through firewire it can also support the modest power supply so that we can charge up the devices. Firewire has some versions, Firewire 400, Firewire 800, and IEEE 1394B. And these are the data transfer, maximum data transfer speeds. Though the first version was supported 400 megabit per second, it was higher than USB 1. Later on, we had 800 megabit per second and 3.2 gigabit per second. And here you can see now why we are not using firewire, because the latest version has supported 3.2 gigabit per second, whereas USB 3 has 5 gigabit per second. So it is higher than the latest version of the firewire. So that is why now it is firewire is getting a bit obsolete. Hot swapping means you can just connect and it plug and play. You just plug it and you can use it. Got it? You don't need to install any sort of driver software because automatically the system has that support. This is called hot swapping.
Sir,
Now
the firewall की daisy chain, yeah, supported.
it is also supported by the DGCN.
Okay, sir.
It can support 63 firewire devices. You can see. Now DVI, apart from the communication or serial port, the DVI interface is there to connect our LCD screens, our projectors. I'm sorry that I could not collect the DVI, the picture of any DVI image, but you can search in Google that you can get the DVI image. DVI stands for Digital Visual Interface, and what is the main feature of DVI? Actually, DVI picked up a strong copy protection system called HDPC, the High Bandwidth Digital Content Protection. And for the HDDP industry, the DVI is the first choice after the serial port or after the RS-232F port or the communication port, the COM port. Later on, HDMI is the latest and greatest, we can say, for the digital video, for the, and you know, you have been using the HDMI in your even in your computer laptops. and the DVD players, Blu-ray disc players, cables, even the satellite set-top boxes. Nowadays, we are using Akash or any fiber set-top boxes in our home. We are using the HDMI interface, high definition multimedia interface. Even with our multimedia projectors, we are using. And the main feature of this is that it supports very high speed data transfer uh, in between the computer system and peripheral devices, or in between the microprocessor system and the peripheral interfaces. And new trend, already I have talked about the isochronous, and you know that USB and FireWire, they both supports the isochronous. And what is isochronous, I have discussed. Now I will discuss about a bit legacy interfaces. One is SCSI. SCSI, you may heard the name, and you have seen this sort of interfaces in earlier days. And another is Internet SCSI, iSCSI, you can say. Uh, Mostly this is a technique for interfacing this storage to a computer via internet. And you can say that our network interface cards supports that iSCSI. And SCSI, that for small computer system, for our personal computers, a technique for interfacing computer to high-speed devices, hard disk, tape drives. Though after the introduction of SSD, these SCSI components no longer we are using. But still, to connect our hard disk, tape drives, compact disk, DVDs, SCSI components or SCSI interface are used. And you can say that SCSI is a system interface. Whenever you open your casing or the computer box, you can see that your hard disk is connected with some huge size bus, and actually that is connected through the SCSI interface of the motherboard. And it looks like this is an example just I have included, and this is the SCSI interface as a whole. I've just included the names for your just introduction only. Now I'll talk about the two networking type interface. One is InfiniBand, another is fiber channel, and both are both supported the serial data transfer. Serial data transfer means bit by bit the data transfer between the components, the sender and receiver entity. And InfiniBand is a serial connection or bus that can carry multiple channels of data at the same time. That means multiplexing is supported by the InfiniBand. This is the connection, this is an interface. And where we actually use this? First of all, it can support data transfer speed up to 2.5 billions of bits. So can you guess in which sort of devices we use? Actually, we use in the networking devices where we can connect our networking copper wire or fiber optic cables. Specifically, whenever we are using some switch or router where our SFP modular ports are there, where more than 1 gigabit per second data rate needs to be transferred. At that devices, we have to use this InfiniBand. Nowadays, the modular switches or modular routers have the InfiniBand interfaces. And you see that it connects the fiber optic cables or the high-speed copper wire cables. You know that nowadays we are using the gigabit Ethernet in our even in our PCs. We are connected the gigabit Ethernet network interface card. So whenever we are transferring the data, though our PC doesn't need to maximum speed, nowadays we are using maximum maybe 200 Mbps or 250 Mbps, even for high speed 300 Mbps. But 1 gig is dream nowadays for me, for us. Maybe in coming future we'll use the 1 Gbps connectivity. At that time, our network interface card will send the data at a speed of 1 gigabit per second. Even 10 gigabit per second is not dream in coming days. And for those sort of connectivity, for those sort of data transfer links, we have to use the infinite band. Our networking devices connects with this interface. And another is, as the name implied, you can see fiber channel. It's also a serial high-speed network interface that connects the computer to multiple input-output devices, and it can support specifically for, you see, it can connect a computer to multiple input-output devices. That means from here you can understand that toward a server, PC, we have to connect through a fiber channel, and it can support a data transfer rates up to billions of bits per second, but can support the interconnection up to 126 devices. So it has some limited capacity, that with the server PC, the network interface card in a server PC, that should include the fiber channel interface to connect a maximum 126 devices. If you need more than that, in that case, just add up with some other interface cards. And most of the server PCs, specifically with Xeon processors, that can have some modular expansion slots where we can include more and more fiber channel interfaces. And if you include one fiber channel, you can connect up to 126 devices. Okay, that's it, and I like to finish this lecture today so that I can start with a new lecture in the next Friday, and that will be our last lecture. And just give me 5 minutes. Within 5 minutes, I can finish, inshallah. Okay, now the interfaces so far we have talked about, those mostly are wired interfaces. But nowadays, our devices, our embedded devices or embedded system, computing devices, IoT devices, those mostly depends on the wireless communication. And in wireless communication, we have two frequency. One is infrared IR. This is a higher frequency than the radio frequency, and another is RF. And of course, though it's a higher frequency, but it's relatively cheap because we are using, you know, that it's a more hazardous. Infrared is bit hazardous signaling technology. We cannot use for data communication, but for some specific signaling, for short-term signaling, we can use the infrared, and it is relatively cheap. In that sense, it needs line of sight, and we use some diode to emit the infrared signal, and in the counterpart or in the receiving part, we need some transistor to detect that signal. And the very common example of infrared signal nowadays we are using at our laser pointers or even at our remote controls, remote devices that we use for our televisions, or to connect any or to control any device or home appliances. Now, on the other hand, we have the radio frequency based interfaces where line of sight not necessary. We can cover longer distance. In this case, we cover shorter distance. And we can use frequency hopping to communicate while constantly changing the transmission frequency. Means we have a variety of frequency. I think you in your computer networks or in your data communication course, you have studied the frequency, signal, spectrum, these terminologies. And as we are having a variety of frequency channels or sub channels, the devices can hop from one frequency to another frequency. So this makes more flexible through the wireless communication. Now I'll talk about that, what interfaces we are using the wireless communication protocols. The interfaces with wireless protocols, that is the infrared data association, the thing I have just talked about, that IRDA is an international organization. This is the standardized organization for infrared data association. And this is designed to support transmission between two devices over short range, from point to point infrared, from TV to your remote control, from laser pointer to a just from the laser pointer, we are just putting the signal towards a background. And the data transfer rate, you see, very small, 9.6 kbps to 4 mbps. Very, very small data rate. And deployed for notebooks, printers, PDS, cell phones. And the operating system is also supported by the Microsoft for the computer systems. And it is also available on several popular embedded operating systems or devices. Now, the most widely used interface that is also depends on the wireless technology. A Bluetooth interface. Yes, we are connecting our, the most commonly we are connecting our keyboard, mouse and headset with the Bluetooth interface. And the Bluetooth is a wireless technology which is used for computers and personal digital assistants, mobile phones, headphones, mouse, keyboards. Even for our just few days back, I have purchased a very good quality sound system for my office, and where the Bluetooth that is Bluetooth supported, and the sound quality is so nice. And for the Bluetooth, one thing I should mention that for the infrared, yes, it's free of cost. The signal is free of cost. We don't need to purchase because we are using for a shorter range of communication. But for Bluetooth, we are using a frequency band that is in between 2.4 to 2.4 gigahertz at our area or in the global area. Or for Europe and America, we have the 5 gigahertz frequency band. Okay, nowadays 5 gigahertz even available in our country. And typically we say that short range distances typically up to 10 meters. Okay, no problem. Beyond 10 meters, it can support, but within 10 meters, you good quality of a data transfer rate. And the Bluetooth transfer speed up to 1 megabit per second, 1 Mbps. Whereas this is 4 Mbps, but Bluetooth can support 1 Mbps. Now, this is not an interface, rather it's a standard. I have two more slides. This is one is interface. The interfaces we are using for our Wi-Fi connectivity. And you know that we have a Wi-Fi module, and that is an interface. Wi-Fi module is an interface that is built in each and every device nowadays. Even in your microcontroller based system, in your laptop, in your mobile phone, in your tab, in your PC, everywhere. Even in our home appliances, we have an interface that is the Wi-Fi interface. We say Wi-Fi module, and that is supported by a standard name IEEE 802.11. I hope that you have studied this, and there as well we have to use the request to send, clear to send, data and acknowledgement. And the maximum speed nowadays, the latest version of 802.11 that can support up to 600 Mbps, and we are looking for the gigabit per second data capacity or data rate. But it started with 1 Mbps. The very earlier version in 1997, the 802.11, that was started with 1 Mbps data rate. But nowadays, with varieties of technological advancement like MIMO or the 5G connectivity, we are achieving 600 Mbps, even more than that. And the most important thing is that we are allowed to use the unlicensed band. We don't need to pay anyone or to the government for using this standard or for using this sort of Wi-Fi connectivity. And the data medium access technology we are using, that is based on CSMA, carrier cells multiple access with collision avoidance. Last one of today's lecture. This is the last slide. This is the wireless protocol. With the by the time we are passing by, and we are passing the COVID-19 pandemic, and here we have seen that the use of body sensor networks, that multiple devices are connected or embedded within the body, and we have our personal digital assistants, PDA or smartphones. Those are connected via apps, and based on our motion, it can collect the data, and thereupon the data can be stored through LAN, wireless LAN, or through the mobile uh, network. It can be stored anywhere in the cloud, in the hospital cloud, or for it can be available to the doctor. So this is a typical structure, and this sort of embedded use or this sort of system is developed based on some particular standard, that is IEEE 802.15.4. And this is a standard proposed for wireless personal area network, because this is a personal information. We say this is a personal area network. Basically, this is designed for star topology, and it has a maximum data rate of 250 kbps with the unlicensed band. It also supports the unlicensed band. We don't need to pay to the government. You know that BTRC is there, Bangladesh Telecommunication Regulatory Communication. If you are starting any GPRS or any radio transmission, in that case you have to pay that. But if you are using your home appliances with the wireless LAN or Wi-Fi network at your home, the frequency you are using, the channel you are using, you don't need to pay that to the government for that. And that is why we say that we are using the unlicensed frequency band. And the technology, I've just summarized the information about 802.15.4, and the technology, the medium access technology, it supports by this standard is that CSMSCA, carrier sense multiple access, and also time division multiple access. So it is contention based and it is contention free. So the hybridization of both contention based and contention free technique is included for 802.15.4. Okay, so that's it for my side for today. I've taken a bit longer time because I like to start with a new lecture in the next class, and this is all about our all sorts of external interfaces. Though I have started with an internal interface of 8251, but later on I have talked about all the interfaces, all the available interfaces nowadays we are using for our regular day lives, and those all are uh, or external interfaces. That's it from my side. Do you have any question? Sorry. So up to this 12 lecture has finished, and hopefully we'll have another lecture, that is IoT protocol, that is the LoRa protocol. I will discuss on next Friday. And today we'll have the lab at 3:15, right? Akib.
Yes.
Okay. So and I have seen that 10 students have uploaded the assignment. So please upload within 2 and complete that task, inshallah. So see you in the lab, inshallah.
Sir, I have been having some problem with my Proteus. Can I show you the problem after this class?
Now, yes, you can show me now.
So
Yes, you can share your screen.
sir, so like the task that you did in class, I try to replicate it, and whenever I'm like giving it to like animate it, the this segment is just starting for 1 second, and then it just goes off and it does not turn on anymore. And it's been happening with the other tasks as well. For example, the with this also, like when I'm starting the animation, it just starts for a second and then it just turns off, and I am not being able to solve this.
Okay.
And
So any one of you or others are facing the same sort of problem? I guess no.
For 7 segment display, my display actually turns on and then never turns off.
And sir, another thing is like in this settings, I try to give it the internal memory size, but when I press OK, it again reverts back to the internal.
It doesn't. So you just give it now. You just give it now.
Yes, I gave 1000 and
Okay. Just and now play it.
so it's the same.
Let me check your connections. Is all the connections are okay or not?
পিছন দিয়ে যান না, এখন না, পরে।
I think everything, superficially, what I've seen, that everything is okay. So, just a suggestion that can you reinstall your Proteus again and run the code? Okay, just
Okay.
a suggestion that if everything is okay, then just reinstall it and run the code again. Okay, so
Okay.
let's give it a try. Okay, and I'll discuss about it in the during the lab class, inshallah. Okay.
Okay, sir. Thank you, sir.
Allah Hafiz.